All right, folks, welcome back. Hopefully you were able to watch the video okay yesterday. We did start chapter 12. I'm going to continue that today, but I do want to remind you that we will take the chapter 10 exam when we get back from break. And so we will review. So I will have a review session. The review session then will be, I forget what day we come back, but I will post it on Classroom for us. So please make sure you check Classroom. Um, and look at the day that we're going to review. But I will mention that again when we come back. But the exam will be then when we get back from chapter 10. The exam will be on chapter 10 when we get back from the review. We will meet during the review session. We will meet and I will go over the procedures with you on how to take the exam through Edmodo, which is a platform that I've chosen to use to give you the exams and quizzes as we move forward. And so I need to explain that to you as well. And so we'll go over that and we'll review the material for the chapter 10 exam when we come back from break. Okay. But we do need to continue on with with the new material here. And we started the new chapter. And in this new chapter, what we will be doing is we will be looking at the quantities. So in chapter 10, we talked about chemical quantities, that is the amounts of substances that we looked at, so elements and compounds, and how we were able to describe how much of those elements and compounds we have in terms of mass, in terms of the volume, and in terms of the unit mole that we learned about in chapter 10. What we're going to do in chapter 12 here is we're going to take what we learned in chapter 10 and basically combine it together with what we learned in chapter 11, which was about chemical reactions and writing out chemical equations. And so chapter 12 here is a culmination of all the information that we learned in chapter 10 and in chapter 11. And we're going to combine it together because what we want to be able to do when we do chemistry is we want to be able to describe what happens during the course of a chemical reaction. And we learned that in chapter 11. We were able to describe it in terms of the reactants and the products. What we want to do then also is we want to add to that a description in terms of quantity. How much of the reactants do we need and how much of the products do we form? And that's the basis behind stoichiometry. And we're going to start with that today. But just like with what we did in chapter 10, with chemical reactions, in order and describe it in terms of the quantities involved in a chemical reaction, what we need to be able to do is we need to be able to make sure that we can obtain the correct formulas and the correct formulas, because that will be absolutely important in getting the quantities that we need. So starting with number 3 here in your problem set, let's go ahead then and answer the questions here. Either you write write the formulas for the first two, and the names of the compounds for the second two. And folks, if this is something you're still having trouble with at this point in the semester, please make sure you come see me, and so we can work through this. I can provide you some help, some ideas on what you can do to learn how to write out these chemical formulas. But the first two in this problem set here will be helpful to you. And so make sure you're able to write these formulas down. Writing the names of the compounds, not as important for calculating the quantities, okay, but you should be able to do so as well. So for the first two, write down the formulas. For the second two, try your best with the third one. Okay, that's an acid, and I just want to use that to talk about acids really quickly, and then we'll go. Okay, so the very first problem today, what I'd like you to do, answer number 3 in your problem set, and this is for the chapter 12 problem set. Okay, take about 3 minutes to answer this question here. And then when you get back from, and when you finish and submit your answer and you unpause the video, we'll go over it. Okay, so go ahead and get started with these 4 right here. Okay. All right, so hopefully you had a chance to work through this one. Like you said, it's fairly important. It's very important that you're able to come up with the formulas for these compounds here. And so for the very first one, they give you the name of the compound. You have to be able to come up with the formula. Hope you recognize that this is an ionic compound because you have a metal and a non-metal section here. Hope you recognize that this non-metal, the anion here, is a polyatomic anion, which you have to memorize. All right, so with that said, then you should hopefully come up with the formula. Then it's K2PrO4. That's the formula for potassium chromate. Okay. Same thing holds true here for the second compound. You have an ionic compound because you have your metal here, sodium's a metal, and then the non-metal portion again is a polyatomic ion, again, which you have to memorize. Go back to chapter 9, and make sure you memorize that, okay? So with that said then, the formula for sodium hydrogen carbonate is NaHCO3, okay? And hopefully you got that down, okay? All right, for the remaining two, they give you the formula, you're supposed to come up with the name, okay? Now, for the third one, this is an acid. We will talk about acids and bases. My hope is that we will be able to get to the discussion of acids and bases towards the end of this semester as we get closer to the summer. But the acids then are ionic compounds. So all four of these compounds here are ionic compounds, okay? The only difference between the ionic compound here is, if you notice, there are no metals. There is no metal in this particular compound. However, in all acids, the hydrogen ion is your cation, and everything else is the anion. Okay, so this is the permanganate anion. So this is what we refer to as permanganic acid. And we will learn how to name these acids, okay, when we get to the unit on acids. Okay? And but I do want you to make sure you remember then that acids and bases, when we talk about these types of compounds, they are also ionic compounds, though they do not look like ionic compounds because there's no metal in it. Okay? All right, so with that said then, hopefully you see with the last one, this is an ionic compound because there it is, that's the metal, so that's the potassium metal, okay, and this is the non-metal portion here, C2O4, that's oxalate, so the compound here is potassium oxalate. Okay. All right. So make sure you write down those answers, folks. And like I said, if you have any questions on how we obtain these the answers here, and make sure you come by and see me. I will have one last office hour this afternoon between 1:30 and 2:30 before we leave for the break. Okay. So come by and see me then if you have any questions on how to come up with these the names and the formulas for these compounds. Okay. All right. Let's go ahead then. Let's continue on. We were talking about what we will see in this chapter here, and I kind of went over this with you already. We will be talking about chemical equations. We're going to get back to chemical equations again. We kind of left the discussion of chemical equations behind a little bit in chapter 10, but we're right back into it again. Now remember, once you finished your writing out your chemical equation, you have to be able to balance it, and you balance it by writing those coefficients in front of each of the reactants, in front of each of the products, to make sure that you balance out the atoms. What we're going to learn in this chapter then is we're going to learn about what those coefficients actually mean. So how do we interpret these coefficients here in order then to make sense of what the equation is telling us? So we need to know what those coefficients mean. And the very first thing we're going to do in this chapter is we're going to learn how to interpret these coefficients. And then what we're going to do then is we're going to get to the conversion part. So we will convert. So we'll talk about how we can convert between, and I'm sorry, I'm going to change this real quickly. Convert between the different parts of a reaction. That's going to be the conversion that we're going to be doing in this chapter, and that's going to be the basis of our stoichiometry. And then towards the end, then we're going to talk about how we can decide which one of the reactants went out first, what we call the limiting reagent. And the reactant, why we need to discuss that is because that limiting reactant, this limiting reagent, determines then how much product we get. And the whole idea behind doing this, the whole idea behind doing stoichiometry is being able to use a chemical equation in order to predict how much product we're going to get based upon the reactants that we have to start out with. And that's the whole idea behind calculating these limiting reagents as we move forward. Okay. All right. So what we're going to do then is we're going to start out by talking about these chemical equations. Okay. We're going to talk about how we can use the coefficients to discuss and to describe the chemical process, the reactions going on. But do make sure you understand this, folks, that when we talk about chemical reactions, we actually use the chemical reaction is a set of instructions. That's how you want to think about it. We use instructions on a daily basis to get things done. We follow recipes. For some of us who cook, we follow recipes in order to cook with and to bake or to cook something. We follow instructions on how to put together a bike or to put together a shelf, but we follow instructions as well. And so the way you want to proceed with this is you want to be able to look at these chemical equations as a set of instructions that you need to put together the chemical products that we have. So that's what you want to make sure you see with these chemical equations. And so they're just a set of instructions, very much like a set of instructions that you use for cooking or putting together a toy, or whatever other instructions you use throughout your life. Okay. All right. So what do instructions have to do, especially what are a good set of instructions? Well, whenever you have a good set of instructions, it will provide for you the components that go into making your toy or your cookie or whatever you're cooking with, but it also describes the amount of each. Okay, so you need 2 cups of flour to make a cake. You need 3 screws to put together a certain part of your toy. Okay, so any good set of instructions have to have a description of what is being used and how much of it is being used. So with the chemical equation, it is no different. For a chemical equation, you have to be given what goes into it, the components of your reaction, and how much. Okay. And so what we're going to be doing in this chapter then is we will be talking about how we describe how much. Okay. So make sure you keep in mind then that when we describe the amounts that go in, the amounts come from our ability to interpret the coefficients and the balanced equation. Okay. And so when we have a good understanding of what those coefficients mean for us and how we can interpret them, we're going to interpret them in different levels. Then we can go ahead and calculate, do a simple calculation. And it's simple after you practice it. So stoichiometry is a set of calculations that we do to compare amounts of the components in your reaction. So we can compare reactants, we can compare reactants to products, we can compare products. The whole idea behind stoichiometry is we're comparing the amounts that are given to us in a chemical reaction. Okay, and we want to do that because we want to be able to describe then how much of the products we will get, how much of reactants that we need. And so chemists use stoichiometry, which is, again, it's a set of calculations based upon the balanced equation of a chemical reaction. Okay, so it's a set of calculations that is based upon these balanced equations here. Okay, but what we can do with these, what chemists do with these then, is we are able to predict them, the amounts of reactants and products that we will, that's required in that particular reaction. Okay. All right, so then what we're going to do then is we're basically going to use ratios, okay, ratios in order to describe then the relationship between the different components of a chemical reaction. Okay. All right. So let's go ahead then. Let's talk about how we can interpret a chemical reaction, a chemical equation, and use that to describe then. And the whole idea then is we want to be able to describe it to indicate the quantities of atoms and molecules, of moles, of mass, and of volume. These are the quantities that we want to use to describe then the components of a reaction. Okay, so that's what we want to be able to do at the end of this process, is be able to interpret the chemical reaction, okay, the chemical equation in terms of these different quantities here. Okay? So a balanced equation, what it does then on the most basic level, what a balanced equation does, and we already talked about this, it describes the number of atoms in the reaction. It describes then the total number of atoms that are described in the reaction. Okay? And so what you need to make sure you do is, and remember this, that when we balance the equation, we're trying to make sure that we balance out the atoms on both sides of the chemical of the equation. Okay, so let's go ahead then. Excuse me. Let's take a look at an example about an example of an equation. So let's go ahead, and this is the equation describing the formation of water. I'm leaving out the states for us right now, okay? And we're going to write the most basic parts of it. Okay? The balanced equation that describes the formation of water from its elements. This is a synthesis reaction that shows us that. Okay, so when we balance out this equation here, what we notice then is we have to put a 2 on this side here to balance out the oxygens, but that gives us 4 hydrogens here, and so we have to put a 2 in front of the hydrogen here. Okay, so when we count atoms, and remember when we balanced equations back in chapter 11, what we did here was we counted atoms. So on the left-hand side here, we have a total of 4 hydrogen atoms. We have 2 oxygen atoms, and then on the right-hand side, again, hydrogen, then we're going to have 4 hydrogen atoms, and from 2 water molecules, we also have then, 4 hydrogens. Let me write that in. 2 oxygens. On this side, on the right-hand side, on the product side, we're going to have 4 hydrogens and 2 oxygens as well. So that both sides then have an equal number of hydrogens, an equal number of oxygens. And that's the whole idea behind balancing the equation. But now you have to be clear, what those coefficients tell us is the total number of atoms that are involved in the chemical process. And if you notice here, when you add up all the atoms on the left-hand side, and you add it up, you have 6 total atoms on the left-hand side to start out with. And if you take a look at on the right-hand side, you have 6 total atoms on the right-hand side, so that the total number of atoms have to be the same. The number of atoms are conserved. And we learned that when we learned Dalton's theory, we were told then that during the course of a chemical reaction, the atoms rearrange, they change how they interact with each other, but the number of atoms and the type of atoms stay exactly the same. And that's exactly what we see here. We start out with 4 hydrogens, we end up with 4 hydrogens. The number of hydrogen atoms don't change, and we don't change hydrogen to some other element during the course of this reaction. Okay, so, and the same thing holds true for oxygen. We start out with 2 oxygens, we have to end up with 2 oxygens. And so on the most basic level, we can take a look at a balanced equation and determine then the number of atoms that we start out with and the number of atoms that we end up with. They have to be the same. If the balanced equation is correct, it has to be the same. Right? So make sure you understand then that's what we have for a balanced equation. Okay? All right, so let's take a look at another example here. Okay, so we have then, this is what's called the Haber process. I gave you the balanced equation already. Okay, and let's go ahead then, let's interpret this equation in terms of the total number of atoms. Okay, so based on the balanced equation, we have a 1 in front of the nitrogen. Nitrogen, and this is elemental nitrogen, is diatomic, which means then we have 2 nitrogen atoms on the left-hand side, okay? And to that we have reacted, we have combined, since it's a combination, 6 hydrogen atoms. So we have 6 hydrogen atoms here. On the right-hand side, we form ammonia here. That's a molecule, but we have 2 of those. So if we have 2 of those, we will end up with 2 nitrogen atoms and 6 hydrogen atoms, which is what we expect should happen if the equation is balanced correctly, so that we have a total of 8 atoms on the left-hand side and 8 atoms on the right-hand side, so that the number and type of atoms have to be exactly the same. So that's the basic level. So we can look at this balanced equation here. We can look at this balanced equation here and obtain this information here about the atoms. Okay. Okay. So with that said, then what we have is the ability to be able to interpret that. Okay. Now with the balanced equation, then it also tells us how many molecules are involved, and also the number of units, formula units, are involved in a chemical reaction. So basically, the number, the amount of a particular compound or an element that's involved in the reaction itself. Okay, and so the ratios then, okay, between reactants and products, with the number of atoms, okay, should be the same, okay, on both sides. And so with that said, that taking advantage of that fact will allow us then to do the stoichiometry that we're going to be doing. Okay, all right. Okay, so with that said, then let's go ahead and let me ask you. Let's go ahead and interpret this equation then. Okay, interpret this equation in terms of the particles that are involved, not just single atoms, but let's go ahead and let's talk about the particles involved in this particular reaction. Okay, so now then we're going to count particles. Okay? And in this case, then the particle then will be the molecules. Okay, so we're going to count the molecules that are involved in this particular compound. Okay, so in this particular compound, then we will have 1 nitrogen molecule combined together with 3 hydrogens particles, okay, to produce then for us 2 ammonia particles. And that's what we have described for us here. And make sure you keep this in mind then, that when we talk about this particular level of interpretation, okay, we're looking at the particles as a whole. So we're starting out with 1, so the coefficient here is 1. We have 1 nitrogen, okay? And so again, we're not counting atoms here, we're counting the total molecules. We have 1 nitrogen molecule combined reacting with 3 hydrogen molecules to form 2 ammonia. And if you notice then, if you add these up here, okay, we have 4 total molecules on the left, okay, and we only have 2 molecules on the right. And if you notice here, the number of total particles does not add up. Number of atoms should add up, but the number of molecules, total particles, will not add up. Okay. All right. So with that said, then let me ask you to do this. Okay. I've run out of time here. I want you to take a look at number 14 in your problem set. What number 14 is asking you to do here, it's asking you, and I want you to do this on your paper, okay, and for submission. It's asking you to interpret this in terms of total number of atoms and in terms of total number of molecules. Okay? So what I'd like you to do, we'll start with this on our, once we get back from break, we'll start with this problem here, okay, and I'll review with you what we're doing. But I'd like you to submit for your work today, to finish out the total number, interpret both of these equations in terms of total number of atoms and total number of molecules, and submit that so I can take a look at it. And then we will use this particular problem when we get back from break to review what we've talked about up until this point. So I'll use this to review for you at that when we get back from break. And then we'll use this to move forward, and we'll talk about how we can interpret these equations in terms of moles, in terms of mass, and also in terms of volume, especially if these the reaction involves gases, okay, at STP. All right. So with that said, then have a good break, folks. Try your best to find some rest and have a restful break. And I will see you back here on when we get back from break. Okay. Have a good break, folks, and have a happy Easter. Okay.